Welcome to Justice Today, the official podcast of the Department of Justice's Office of Justice Programs, where we shine a light on cutting-edge research and practices and offer an in-depth look at what we're doing to meet the biggest public safety challenges of our time. Join us as we explore how funding, science, and technology help us achieve strong communities.
Welcome back to the show, everyone. My name is Marie Garcia, and I'm the Office Director for the Office of Criminal Justice Systems at NIJ. I'm excited to be back and talking about NIJ's Graduate Research Fellowship Program with one of our recent research fellows. I was a fellow as well, and I received amazing support from NIJ during my doctoral program. And I love hearing about the work being done by our fellows today. Joining me to talk about her research on organic gunshot residue is Dr. Shelby Khandasammy. Welcome to the show, Shelby.
Hi, thanks for having me.
So to start, Shelby, tell us a little bit about yourself.
So, I finished my PhD in chemistry with my research focus being in forensic chemistry from SUNY Albany under Dr. Igor Lednev in December 2022, so last year.
Great, congratulations.
Thank you.
So today we're going to talk about your dissertation research, which focused on, as you just mentioned, gunshot residue. And before we get there, can you tell us about the differences between processing a crime scene in real life compared to what we see on popular TV crime shows?
Processing a crime scene looks very straightforward in crime shows, but it's very different in real life. It's highly glamorous, as most things with TV are. Usually they find a perfect fingerprint or a perfect spent bullet or DNA just laying there in pristine condition, but crime is messy and not every scene will have DNA or bullets or more of the really specific evidence types that we can link definitively to a person who has committed the crime. So it's not always so neat and easy, and we're not always able to specifically find evidence that can link us to a specific person.
Okay, great. So let's start with the basics for listeners who, like me, are not forensic scientists. I'm not a hard scientist. I'm not a bench scientist. I did do well in biology and chemistry in college, but I still don't know a whole lot about this line of research. So, can you tell us more about trace evidence and specifically gunshot residue and the work that you've done?
So, the concept of trace evidence is that every contact leaves a trace. So, whenever we have a perpetrator, a victim, and a crime scene, between those three, we're going to have different interactions and we're going to have traces or trace evidence that's generated between those interactions. And gunshot residue itself is a type of trace evidence that is produced when we discharge a firearm. So, when we discharge a firearm, a lot of times in TV and movies, you'll see a big plume of smoke happen. And in that plume of smoke, that's where we find our little particulates or our gunshot residues. And these settle on the surface of people's skin, their hair, their clothing, the crime scene itself.
So, with gunshot residue, as you mentioned in TV, you see like this burst of smoke. You see that in movies as well. Can gunshot residue be washed off?
So, gunshot residue is kind of akin to tiny particulates like sand. So, of course, it can be washed off because that's physical movement. However, we've been turning to other locations for sampling, like your nasal fluids, because people don't often clean out their noses after a crime, or hair or clothing. And oftentimes, if you get to gunshot residue quickly enough, you could recover it.
So, tell us about the importance of gunshot residue.
So, my work primarily focused on the analysis of organic gunshot residue, which is one of the two subtypes of gunshot residue. There's inorganic and organic gunshot residue, and recent research has turned to organic gunshot residue as a really important potential trace evidence type. And there's a couple reasons, but one of the major ones is that it has shown great potential to point us to a specific type of ammunition and caliber.
When we were preparing for this discussion today, you mentioned how important it is to distinguish between bullets and cartridge casings. Why is that important?
So, uh, as a whole, like people are more familiar with the bullet. You know, when we see crime shows and sometimes when we talk about ammunition cartridges themselves, we often call it a bullet, but it really is an ammunition cartridge as a whole. And there's several components within. You have your bullet or your projectile that flies out of our firearm upon a firearm discharge event. And below this, we have the things that actually make that combustion reaction happen, which are our primer and our propellant. And our propellant is smokeless powders or tiny explosives you can picture. And our primer is shock sensitive. So when we pull the trigger, what actually happens is you have a firing pin that hits your primer, and then we have some combustion that happens there. And this ignites our propellant or our smokeless powder. And our primer and our propellant are actually what create our gunshot residue particles.
Great. Thank you so much. So let's get into your research. So, what drove you to do this research for your dissertation?
For us, we looked at the field and what we'd done in the past with gunshot residue because we worked on a previous NIJ grant. And what we found was that organic gunshot residue was taking off. There was great interest in it as a potential evidence source. It seemed to be very informative, much more informative than inorganic gunshot residue. So we thought this is being underutilized. It's a great evidence type. More of it is generated at a crime scene than inorganic gunshot residue. It's easier to find because it's larger. This is awesome. And my lab primarily uses Raman spectroscopy, which is a non-destructive technique that uses lasers, and we get some signature from these molecules, and we're able to identify our sample in that way. So what we wanted to do was develop non-destructive methods for analyzing this organic gunshot residue, see what type of signatures we could get. And the idea was also, there's more destructive techniques out there, but Raman spectroscopy can give you great information, and you can preserve this evidence for later processing or other techniques that might destroy it.
So, the research that you undertook, is it something that we see right now in the criminal justice system? Are there forensic labs that are engaging in this type of work as well?
So, as far as Raman spectroscopy goes, it hasn't really entered the field fully yet. And the reason being is it's new and there's always different standards, right? But we are moving towards it, and Raman spectroscopy is being utilized in a lot of different forensic evidence types. And one thing my lab also focuses on is analysis of body fluids at crime scenes, directly at a crime scene, using Raman spectroscopy. And then I worked on gunshot residue, but people have looked into things like paints, cosmetics, hairs, fibers, and the non-destructive nature of it is really what I think the appeal is. And people are working and talking and moving towards incorporating it, I think, in a forensic lab setting.
No, that's great to hear. NIJ has a pretty robust portfolio of research in this space. So, hopefully, I'm sure your research will add to it as well. So, with regard to your dissertation research, can you break down the types of questions that you were looking to answer with your research, and what were your findings?
Yeah, so we really focused on three major sort of areas. We wanted to detect, identify, and characterize organic gunshot residues better. And we had four projects that I specifically worked on. So we looked at creating a method using fluorescence and Raman spectroscopy for detecting and identifying organic gunshot residues. We also looked at the method by which we could characterize organic gunshot residues better using laser-induced breakdown spectroscopy, which is another type of spectroscopy that's destructive but actually offers us almost fingerprint-like information as it's very specific. And we also looked at the precursor to our organic gunshot residues, our propellant, as I mentioned. And we utilized Raman spectroscopy for that study as well and looked at characterization and differentiating between manufacturers and calibers. So we really looked in three major areas to try to help law enforcement first detect, then identify the organic gunshot residues, and then move into characterization later and get really important information out.
So, how would someone in the field use this research and the findings that you produced?
So, ideally, what we envision in the field is that you would go to a crime scene and collect your gunshot residue, or have a suspect come down to the precinct and you would collect the gunshot residue from their clothing or their hair or their nasal fluid or whatever it is. And you would then take that gunshot residue, utilize fluorescence and Raman spectroscopy to non destructively detect and identify your organic gunshot residues. And then you could use another technique, such as laser induced breakdown spectroscopy, which I used in my research, to help differentiate and identify and get a specific fingerprint that you could then put in a database for gunshot residue and say, okay, this is the type of gunshot residue. It came from, let's give a very general example, like a Winchester 9mm Luger. And you said you didn't fire a gun recently, but we found gunshot residue, first of all. And secondly, we found this specific type of ammunition, and that's linking you to the crime. And while it may not be definitive, sort of a nail in the coffin, so to speak, in that, someone else could have fired that weapon, it is an important tool that could be used in interrogation and also to build burden of proof, because if we have other pieces of trace evidence telling us that someone may have been involved or at a crime scene or just witnessed something, that's really important.
So I listen to a lot of podcasts and a lot of crime specific podcasts that talk a lot about cold cases. Is gunshot residue or can it be helpful to solve cold cases?
It's a really good question. And I feel like, their aging is something that we're really interested in, and how they age and how they degrade over time. I'm not sure, but I would say, based on what I know about their chemical makeup, they are rather stable. They're not something that's going to crumble away into dust or just fall apart, after a year or two, based on my personal experiences looking at samples that we'd had prior to me even starting my project in our lab.
That's interesting because most of the podcasts I hear about, they're talking about blood evidence and like DNA. They don't really talk about gunshot residue. So that's really interesting to hear. So now that you've done your research and we everything is completed for your fellowship, what are the implications and for policy and practice for your research for practitioners in the field? What do you want them to know about your work?
I think what I want them to know about our work is we've really tried to optimize it, in the sense of, we looked at an evidence type that's easier to collect, that's more prevalent, and, is also allowing specific information. So we really want to make it something that is also a technique that is non-destructive, that's helping them to preserve chain of custody, and also a technique that hopefully can be incorporated and almost used in a black box fashion, is like the vision we have. So I think what I'd want them to know is, it's a new technology, it's an innovation, but we are trying our best to make it as accessible, easy, and time saving as possible for them.
That's great to know. So I started the podcast with introducing you as a fellow. So I'd like to ask you about your time in NIJ's fellowship program. So the GRF is one of our long-standing programs here at the agency. We're incredibly proud of the investments that we've made with new scholars like yourself. And I was one myself, so I know how beneficial this program can be. So tell me how you became interested in the program.
So we'd had a couple fellows in our lab previously, actually two, and one of my really good friends who mentored me in our laboratory, he'd mentioned it, and my professor, of course, had wanted me to apply for the program, and my friend who'd gotten the fellowship had this like great experience, and he was like, it really helped my work, and it just got me like all the supplies, everything I needed. It streamlined the process for me. So I was really encouraged by that, to apply. And then I'd previously been working on an NIJ grant, actually, and I was helping my professor working on that grant and writing reports and so on and so forth. So I became kind of familiar with how the process worked, or like, how do we take the grant and make deliverables and write this report and like modify our budget. And I'd had a really good experience with that too. So I was like, this is great. The mission is great. And I think they're very focused on it, and they're focused on giving us what we need to do the work. So I was really interested, I think, just in the sense that it was also just very straightforward, like, just like, we are here. We want to solve crimes and deliver justice to people. Here's the money. Like, it was very nice. I think, there was not like all this red tape or like fluff.
No, that's great to hear. I know the goal of the program is to help students as they finish up. I mean, the dissertation program, it's all very intense and stressful. So we certainly don't want to add to the stress with the program. So that's good to hear. So how was the program helpful to you? I know you mentioned supplies and being able to have what you need to do your work. Did it help you in terms of time and just giving you the resources generally to do the work that you needed to get done?
So I think the biggest supply for me was my computer. And That was mainly because we didn't have a computer. I was working with, when I was working on our fluorescence mapping project, these huge data sets that contain millions of spectra in them. And I would have to sit on our other computer. And this was before I got the fellowship. I'd worked on a previous iteration of the project, and I'd have to sit on this special computer in this almost fishbowl like setup because it was this glass walled thing. I'd have to like leave our lab, go outside, go to this special computer that I had special permissions to work on that they had to set up for me. And I would load that thing, and that computer was the fastest they could offer me that we could access easily. And I think it still took about half an hour to an hour to load one data set, and then I'd have to work with it. So a lot of times I'd have to just go for a walk, or I'd have to load it, maybe run back to our lab and try to work on something. But unless I had my data set, there was nothing to work on. Sometimes my professor would come by and he'd ask to see something, and I'd have to open the file, and we'd sit there for 20 minutes, like waiting. So my computer made the process so great and so easy, and I was able to just open my files and get on with my day, and it never took more than 2 to 3 minutes to open a file. It was beautiful and great. And we ended up working with 3D Raman mapping, which had even more spectra in the maps because we had spectra in the Z direction as well. And that was, that would have been awful on the other computer. I think it would have broken it, and I would have had to pay the university money or something. But that was huge. And also I did a couple collaborations where we went to sites. At least I did two, and the NIJ was really great because at one point one of our collaborators called and he's like, I have time, but it has to be this week if you want to do this project on our instrument. And so I'd contacted NIJ and said, hey, I know this is short notice and this wasn't in our travel plans, but can I go? It's for the work. And they're like, sure, go. Just send us a short justification. It was very easy. So that was really nice.
I was a fellow myself, and I remember one of the huge takeaways for me was just not having to stress about finding extra funding anywhere for my time and just being able to focus on my research. So it sounds like you had a similar experience, that the funding gave you the resources that you need so that you could get the work done.
I think sometimes, I definitely heard with certain grant programs, or fellowship programs, people will have a lot of limitations on them and a lot of questions asked, like, oh, why do you need to go there? Why do you need to do that? And I think with the GRF fellowship, I did not have that experience. I just justified myself, and they're like, yep, go, that's great. We want you to do the work. So that was really encouraging. I think the level of trust and support they gave was also really encouraging because I felt that they treated, even though you're a student, they treat you as a fully fledged scholar, as someone doing important research. It's not, you're not just a throwaway, you know what I mean?
It sounds like you had a really great experience in the GRF program, which is great to hear.
Yeah.
So I want to thank you, Shelby, for joining us today and for sharing a lot more about yourself and your expertise, and especially your time in the program. That's really helpful to hear. So I want to also thank our listeners for tuning in. If you are interested in science and criminal justice, please follow us wherever you get your podcasts to stay tuned for future episodes. And use the link in the description to sign up for various NIJ topics, including when funding opportunities like GRF are released each year. Thank you so much.
To learn more about today's topic or about NIJ, visit the links in the episode description and join us for new episodes every month. Opinions or points of view expressed in this episode represent a consensus of the authors and do not necessarily represent the official position or policies of the U.S. Department of Justice. Any products and manufacturers discussed in this episode are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice.